Have you ever experienced a moment when a system that worked perfectly yesterday suddenly behaves unexpectedly today, with no apparent changes to its core code? Or perhaps an environment that was supposed to be identical to another starts showing subtle differences in behavior. Configuration drift in cloud deployment environments refers to the phenomenon where the actual settings and characteristics of your deployed resources diverge from their intended or desired state. It is the subtle, often unnoticed, divergence from the baseline configuration that you defined and expected. This divergence fundamentally challenges the principle of consistency across environments. It arises primarily because infrastructure in cloud environments can be altered manually or through automated processes that are not managed centrally. When a developer or operator makes a direct change to a server, a database setting, or a network rule without updating the infrastructure as code definition, that environment begins to drift. Over time, these small, unrecorded changes accumulate, making the environment unique and difficult to reproduce or troubleshoot. Understanding this is crucial because it directly impacts system reliability and security. Imagine you have a production environment and a staging environment that should be identical. If one has configuration drift, tests run in staging might not reflect how the application will behave in production. This can lead to unexpected outages, security vulnerabilities, and compliance issues, because the documented or baseline configuration no longer accurately represents the deployed reality. To counteract this, organizations widely adopt infrastructure as code, or ISC practices. Tools like Terraform, CloudFormation, or Ansible allow you to define your infrastructure in declarative code. This code then becomes the single source of truth for your environment. When a change is needed, you modify the code, and the ISC tool applies that change consistently across all targeted environments, preventing manual, unrecorded deviations. This ensures that every deployment aligns with the approved blueprint, making environments predictable. Ultimately, managing configuration drift is about achieving deterministic deployments. By actively preventing and detecting drift, you gain greater control over your cloud infrastructure. This leads to more reliable applications, faster debugging cycles, enhanced security posture, and a significant reduction in operational overhead, because you are always working with a known and validated state.
If this helps you code smarter, like, subscribe, and stay tuned for more.